Hello, everyone. I will be talking about securing and attacking Kubernetes. It's going to be a little more attacking, and securing is like afterwards. So I am Vincent. I work at the KPN CERT team, which is the CERT team of a great Dutch telco. It's called the Royal Dutch Telecom provider. And I used to be working in the red team. Now I joined the CERT team, and I do a bit of both ways, actually. And I really like to work binary stuff, but occasionally I get intrigued by some web application technology as well, or some orchestration technology like this one. This will be my talk. I will first talk about what Kubernetes is, who developed Kubernetes. Then I'll talk about how to interact with Kubernetes and the Kubernetes API. Then I will talk about some common pitfalls you might find when setting up Kubernetes and some stuff you can exploit when you're attacking Kubernetes. And then in the end, I will give some advice on how to harden your cluster and your nodes and maybe your pods. And I should say that Kubernetes moved quite fast with development. Like a couple versions ago, they didn't really do a lot of security by default. Nowadays, when you download a new version, a lot of these attacks, they will not work. But still, you will find them in the implementations because it's quite hard to upgrade your cluster without breaking things. So Kubernetes is a container orchestration tool. It is made by Google and is mainly written in Go. Google released it in 2014, and since 2015, partnered with the Linux Foundation, they created the Cloud Native Computing Foundation, and Kubernetes is right there now. I think it's one of the most active Git repositories in GitHub, with the Linux kernel being #1. So it's quite a lot of development going on there. You can get Kubernetes clusters setting up really easy with the AWS EC2, and you can get them from Google Cloud. Also, Canonical offers their own Kubernetes flavor. And you also have Minikube for development, so there's a lot of different flavors going around. In case you're wondering what Kubernetes means, I've been wondering for a long time, until I found out it means helmsman or pilot in Greek. So it's basically steering the wheel of your Docker there. Then the tool you use to talk to the API, the Kubernetes API, is called kubectl. And kubectl is used to talk to the RESTful API on the master, and then each node has a kubelet API that communicates with the master and gets commands this way. You can also use curl if you want to talk to the API, but using kubectl is, of course, much easier. Offensive advice is to download the kubectl binary. It's static, so you can, if you're on a cluster and you pawn the pod, you can just wget from the Kubernetes website the kubectl binary, and it will just magically work. So it's a great post-exploitation tool that is statically compiled and available. So kubectl has namespaces. Namespaces can determine scope, and they can be helpful when setting up administrative boundaries. Kubectl has something called role-based access control. And these security policies can be fine-grained by using namespaces, but also by using tiers and labels for your applications. Here you can see like the default namespaces in the small cluster I set up. You have a default namespace, just there by default. You have a safe space I've set up, and you have the kube system one. And in the kube system namespace, there will be a lot of Kubernetes system applications and pods, like etcd, where all your secrets are stored, and etc. So Kubernetes works with pods. And a pod is a collection of containers that serve a specific purpose. So you can have a pod for, I don't know, as a web server that will keep running, but you can also have pods for microservices that are expendable the moment the job is finished. Images are freely available, and they can be the same as Docker images, and the configuration is mainly written in YAML. Here's an example of listing all the pods in the namespace kube system. You can see there's a dashboard there, there's a controller, there's an etcd where, again, the secrets are stored as a hint, and there are some network controllers and their secrets as well. This is a demo YAML file. It's very simple. You can create a namespace and a name. You can set up a restart policy, what it needs to do when the kube restart. You can set up an image, the version that will it pulls from the Kubernetes repository. In this case, it will be Ubuntu version 14.04. The name will be container, and it will run in the endless loop. And so, it won't end, basically. The moment you set up a pod, you can use the kubectl exec command to interact with the pod. If you set the I flag and the TTY flag, you basically get a bash shell if bash is available. Otherwise, you can get a sh shell. And if no shell is available, you can maybe only execute some other commands. Another abstraction layer that's used for networking is services. You can create pods, and with namespaces, you can set up a service. And a service is actually, you can automatically load balance talking to an application or a pod And then when you can use it to expose expose your service externally. If you use a cloud provider like Google Cloud Native, you can get external APIs be provided to load balancers that will automatically communicate with your pod. It's pretty nice, and it scales really nicely. Another thing Kubernetes has is secrets. Secrets can be tokens, user account tokens, but can also be SSH keys, JWT tokens. You can create your own secrets, and you can combine them really nicely with, of course, the role-based access control. And all these secrets are stored in the etcd pod. And the etcd pod, I think, still uses non-encrypted storage. So if you manage to get access to a Kubernetes cluster and can pwn the etcd pod, then you can pull all these secrets from there. It's basically stored in plain text. So what could go wrong besides storing secrets in plain text? When you go on Shodan and scan the internet, you can of course find many exposed endpoints. You can even find etcd endpoints without authentication that are exposed. You can find the internet-facing Kubernetes API, which has an unauthenticated remote code execution feature that is only patched in newer versions of Kubernetes, so you can find some of them exposed. You can get access to privileged containers through command injection or by regular web attacks. And you can also find the dashboards online or any internal API that is exposed. How I got interested in Kubernetes is when I first joined KPN in the red team 2 years ago. I did an assignment for scanning the internet, see if I could find some interesting systems that belong to KPN. And at one point, I found a Kubernetes endpoint. Like 2 years ago, security was like non-existent for Kubernetes. At least that's what I figured. I found out that all the user accounts were administrated by default. So when I talked to the API, I could easily spawn a pod and scan the internal network of the company I apparently breached because it wasn't a KPN system. And yeah, when I found the Jenkins box, I got very excited, and I completely forgot about Kubernetes for a while. And then I had an internal pen test, and then the Kubernetes story came up again. So if you scan for the internet for the Kubernetes dashboard with Shodan, you can find 16.4K Kubernetes instances available. You can also find etcd. I think there are over 250K etcd services exposed on the internet. And of course, this is not an accurate list. This is only what Shodan finds and crawls for. And if you really want to find interesting ports, I recommend you to scan the internet for port 10,250. That's the unauthenticated Kubernetes API. This is an example of a dashboard that was found on the internet. It was in China. Yeah, it's taken offline now. It's a couple months ago. So yeah, what do you do when you have access to a pod? I have some demos prepared and some examples from what you can do when you have access on a pod. And again, many of these issues I will show, they might have been addressed. They have been addressed in new versions. But a lot of developers, they still apply the patches to make their Kubernetes cluster go back to the old state because it's much easier to administer than set up the role-based authentication. So you will still find many clusters where these type of attacks might still work. This is from a pen test I did. They basically gave me a pod. They gave me like a command injection so I could put the command inside a JSON request, and I could just, send commands and get output back. I created a small Python shell, and the first thing I always do is get a reverse shell back. So the moment I get my reverse shell, you can type printf, and then you see your Kubernetes main API. And of course, if there's no printf available, you can cut proc environ. Also for Kubernetes, secrets, service accounts are usually stored in var-run secrets. By default, Kubernetes automatically mounts service accounts. I don't know any use cases where a web server, for instance, is required to have a service account, because the service account can be used to talk to the API. But you can also choose to not automatically mount these, because a lot of times the service account has some privileges on the API. So you could use the token and the CA cert to talk to the API and maybe try to privilege escalate by there. So yeah, if I try to connect to the kubelet API, you can see that the port is available and I can talk to it. So in this case, you can get kubelet on there and see if you can run my demo. I run another demo inside my demo. This looks really ugly. Anyway, there are some dashboards available here. These are the pods that are running inside my namespace. There is a pod running in countries. It's called Nepal, and there's another pod running in countries. It's called unsafe space. So now we'll list all the services that are available in the namespace, and you can see there are some exposed. And what I will do now is I will create a new YAML file with the security context of privilege, and I will try to communicate to the Kubernetes API that I want to create this new pod. So this new pod is called escape.yaml. I just created it, and I will execute binsh and try to privask on the host. So what I now do in privilege mode, you can see all the block and character devices that are belonging to the host. So I'll try and see if I can find out the hard drive that is actually for the root file system, and I try to mount it inside my mount directory. And as you can see, the host file system is actually mounted inside my mount folder. So now when I cut pathwd, I'm actually in the pathwd file of the host. So that's a pretty easy thing to do. So yeah, what just happened? Apparently, if you have a privilege mode in Kubernetes, which you can check in your settings file over here, it's allowed for you to run, to basically see all the same things and perform a lot of actions on block devices that the node also can do. So if you find a container that is in privilege mode, you can just list all the character devices in dev and the block devices, and you can actually mount the host file system inside your Kubernetes host, which is quite interesting. Sometimes this might not be possible, but then you can scan the ranges of Kubernetes, and maybe you'll find something like a dashboard. Before version 1.7 of Kubernetes, the dashboard was a cluster administrator by default. So if you manage to connect to the dashboard without authentication, you could administer the entire cluster. And since version 1.7 and beyond, they granted the dashboard minimal privileges, and you can still, you need to log in with a service account or with your Kubernetes configuration file. And the Kubernetes website still tells you that you can, with one command, actually give all the privileges back to your Kubernetes dashboard. So yeah, let's say you're in a pod and you cannot create a new pod in privilege mode. You can always try to list for services, and maybe you can see a Kubernetes dashboard, or you can scan the network of your Kubernetes cluster for a dashboard and see if you can connect to it. So my second demo will be just that. Yeah. So we're doing the same thing. We'll try to spawn a new pod again with privilege mode. Listing the namespaces, we can immediately see there's a Kubernetes dashboard available here. And of course, the countries, Nepal and Bhutan are there as well. And I try to spawn a new container, indeed, with the security context privileged, and I get the error message that my service account is not allowed to spawn a pod inside my own namespace, which is how it should be, because you need to be an admin to do that. But the Kubernetes dashboard is available, and I can connect to it. So what will happen now is I will interact with the Kubernetes dashboard and show you how easily you can actually get shell execution there as well. So what I will do now, I will browse through the namespaces. And you can basically click on some secrets. Because you're admin, you can read all of those secrets. You can download CA files, you can download tokens, and you can use those tokens to communicate further with the API. On the left, you don't see, but I will just go to the pods. I will select the namespace default. As you can see, I have full access to the entire cluster. And a lot of times when you do a pen test on a cluster, you will still find that the Kubernetes dashboard has these privileges, because it's very easy for administrators to administer the cluster through this interface. So now I try to open some CA certs, but it's empty. Now I'll try and access some more. And the next step for me will to go to spawn a pod in my own namespace, or any arbitrary namespace. So what I will do, I will go to my namespace. And there's a nice create button in the up right corner where you can paste YAML file, or you can upload a YAML file, and that way you can create a new pod. What I will do, I will name it host escape. I will run an Nginx web server, because that's a job that never completes. I'll give it the privileged security context, and I will try to mount the host file system inside my root directory, and I will name it loot, because there's, of course, a lot of loot there. And yeah, I'll upload it, and then it says, OK, well done. Your host escape is now waiting for creation. And then there's a nice exec feature inside Kubernetes. You can just click it, and it gives you a very nice shell, which I think is pretty cool. So yeah, let's see. All the block devices are there, indicating that I am indeed running in privilege mode. But since I already mounted everything, I can go to root. There you go. I can cut the shadow file. So basically, I'm root on the node using this issue. And I can list all files in any arbitrary home directory. also through this issue, you can immediately previous escalation to the host node. That is because, yeah, again, the administrative boundaries were not set up that well. So yeah, now what? There's another example. This was what I was talking about, the kubelet API being exposed to the internet. A lot of people have port 10,250 exposed on the internet or exposed on their network. And until the 9th of February this year, it was actually an unattended code execution, basically as the administrator on the kubelet API. So if you would find this port on the internet, you can send a request like this, and a file will be created on any arbitrary container inside your network. There's a nice write-up about how a guy found, I think, a miner on his Kubernetes cluster, because yeah, the kubelet API was being exposed on the internet. And now it's authenticated by default, but on port 10,255, there is still an unauthenticated, yeah, I think it's an information leakage, in my opinion, where you can still get namespaces, secret names, but you can also get block device names or other information from the node. And also on HackerOne, I believe, there was a very nice bug. In SSRF on Shopify, they're using Kubernetes for people to set up their own stores. And there was a tool inside Shopify that allowed you to take a snapshot of how your web shop was looking like. So one guy decided that he would like to have a look at the tokens that are on the cluster. And so he managed to get his own service account. And using that token, he managed to query the kube environment variables. As you can see in the authorization bearer, that would be where your JWT token would go, right here. And he disclosed the private keys inside his environment variable and then downloaded the kubectl inside his pod. And he could easily, yeah, he was root on all possible pods from Shopify. Also, all their namespaces, everything was compromised. And yeah, he got a $24,500 bounty for that. It's a very nice feature for you to have in the Kubernetes cluster. So yeah, what can you do about it? How can you protect your cluster against these types of attacks? So it's very important for you to define tiers and labels for instance, front-end and back-end, set up egress and ingress rules. Not all servers need to talk to things on the internet. They don't need to talk to each other. So you can use these labels to set up administrative interfaces and segmentation. And yeah, you should also filter the following service ports if you decide to have your pod exposed on your cluster exposed on the internet. So the kubelet API should not be reachable. The node controller port should not be reachable. etcd and even Calico, they should not be exposed on the internet. But yeah, better do not expose anything on your Kubernetes cluster to the internet. Maybe your websites, but anything that's critical for your cluster is better to keep it inside your internal network. This is an example of how to set up an egress rule. So you can basically say like application foo or application nginx. You're only allowed to talk outbound to port 53. Of course, this won't really protect against data exfiltration, but it's an example of what you can set up. And there are very nice recipes on the link that's below in the slide where you can easily configure your network policies, because it's quite hard, and you have a lot of YAML that you can set up in order to get it up and running. So another advice is to use a SSH Bastion host for your nodes. Only use maybe whitelist an SSH IP for you to administrate the node with. And you can limit your user access by just this one Bastion host. If possible, it's recommended to disable privilege mode, because privilege mode, again, gives you a lot of privileges on the host. That's, I guess, why it's called privilege mode. And you need to set up proper logging, and maybe do not automatically mount service accounts where it's not necessary. And yeah, use the latest version of Kubernetes, because Kubernetes moves fast. I think we're now up in version 12, and when I was doing my testing, it was mainly on 1.8. And there are some tools available now, like a kubebench and kubesec, which is automated benchmarking for you. I think kubebench runs against the CIS standards. Another one, what you can also do, you cannot run your pods as root by default. Currently, that's the setting, and when you're root on a pod, you're also root on the node. And as you could see when I was doing the escape doing privilege mode, I could actually cut all the files on the node. So root on the pod is root on the host. So if you set a strong pod security context, you can say like, okay, I can only use UID 1000 instead of UID from root. And there's also an option inside Kubernetes that is called disable privesc, which is really interesting. I think you should enable it. And there's also one that's called set deny escalating exec, which means that if your pod is running in privileged mode, you cannot do the exec command on it to get a shell. And when you set allow privilege escalation to false, it will break set UID binaries, but it also means that you're not root on the node anymore. And just like any other operating system or machine, you should always check your containers for vulnerable software. This is an example of network policy. This is a security context example. I can say, okay, I run as user 1000. I have a nice volume set up. And in my security context, I say privilege escalation is not allowed. The file system is read-only because, yeah, it would be weird if you would pawn a pod and then go up to the host and you have full write access. And I say, yeah, run as non-root is true. And you can even, in the capabilities, you can block certain syscalls. So you can say, you're not allowed to set up raw sockets. So for instance, yeah, you wouldn't be able to run ping, or you cannot change the ownership of any files. So you can really fine-grade the user control. And if you like YAML, of course, then I think Kubernetes is the platform you should go to. Yeah, and of course, harden the user accounts. Service accounts should be limited, and I think you should not automatically mount your user accounts. You can whitelist your accounts per pod and per namespace, have separate accounts for each namespace, and try to limit your admin as much as possible. For instance, don't run your Kubernetes dashboard as admin by default, and yeah, just apply the principle of least privilege where that's possible. This is an example of a very simple cluster role. You can say like, okay, for the resources, pods, and services, you're only allowed to get or list. Yeah, you can get or list anything that's in pods or services. You cannot write anything there. And luckily, by default, I think this is the setting for service accounts. So Kubernetes is really improving over there. Yeah, we have a lot of time left. Maybe if you guys have some questions. This was the majority of my talk. Yeah, Kubernetes by default had these bad configuration issues. I didn't check a lot in the cloud. But as you could see with the Shopify SSRF, for instance, it's just a configuration that is really difficult for your Kubernetes cluster. So when you install Kubernetes or get your deployment Kubernetes, it used to be very open by default. Everything was admin, everything was privileged. But now what we found is that they're starting to be secure by default, which makes it a lot easier for you to have a secure setup. But the thing was that, yeah, it was just open. And if you look at the Kubernetes GitHub, you'll see a lot of issues and milestones where they basically said, okay, now we're moving to more secure by default. Because I think there was even a CTF from B-Sides in the US that was hosted on a Kubernetes platform. And you would think the CTF guys would secure their platform and their pods were like harder to exploit. But they found out that even those CTF guys, they failed to properly secure the Kubernetes. And one guy got the service account and popped all the pods at once. So yeah, it's just to secure by default, that's the issue there. It should be like that. One question in the back?
Yes, hi. So you were talking about owning the host system from the container,
from the
running
pod,
as root. So Docker can map root user to an unprivileged user on the host.
Yes.
Can you use that to mitigate these kind of attacks?
Yes, it would, because you need to be root in order to mount the block device. So that would indeed mitigate against this attack. Yeah.
Okay, thank you.
Any more questions? No? Okay, I guess.
Anybody else? No? No. Okay, then.
Right, that's it.
Vincent, thank you very much.
Right, thank you.